Magnetic force on a moving charge. The spot on the screen is caused by electrons, which are emitted by the electron gun in the cathode ray tube. Watch the spot as a magnet is brought closer to it. This demonstration shows the effect of a magnetic field on a moving charge. A force on the charge is produced as it enters a magnetic field. Experiments have shown that no force is produced on the charges when the charges are moving parallel to the magnetic field lines. Consider the magnetic field lines perpendicular to a plane. The magnetic field lines perpendicular to the plane appear as points of arrowheads coming out of the plane. A positive charge moving on the plane is also moving perpendicular to the magnetic field lines. As the charge enters the magnetic field, a force is produced and acts on the charge. The force changes the direction of motion of the charge. When velocity and magnetic field vector is perpendicular to each other, the magnetic force is perpendicular to both the velocity and magnetic field. If the velocity and magnetic field vector is at an angle to each other, the component of the velocity perpendicular to the magnetic field vector contributes to the force. This diagram illustrates the vectors' relationship with one another. The relationship can be expressed in vector form or non-vector form. In vector form, the direction is obtained from the vector cross product. In the non-vector form, the direction is obtained by observation of the vectors. A common rule used is Fleming's left-hand rule. The thumb points in the direction of the magnetic force. The forefinger points in the direction of the magnetic field. The middle finger points in the direction of motion of positive charge. When a negative charge is moving in a magnetic field, the force acting on it is opposite to that acting on a positive charge. The force is still perpendicular to the magnetic field, and the initial direction of travel. Here, we compare the forces on positive and negative charges, initially moving in the same direction in the same magnetic field. As the charge is negative, the vector form of the magnetic force gives the correct direction readily. Fleming's left-hand rule is still used, but adjustment has to be made to it. For a negative charge moving in the magnetic field, the force is in the opposite direction to that of a moving positive charge. Care must be taken when Fleming's left-hand rule is used.